Hello, how are you?
I'm great, thank you.
So yeah, just let me know. Well, I make you moderator. I hope it's not too distracting when you get updates who wants to raise their hand. So when you see your colleague, you can just click on their profile picture or on the profile picture and then invite to speak, or let me just know who it is, and then I'll do that.
Okay, sounds good.
We'll wait a few minutes and then, I'll introduce
Sure.
you, and then I just don't have a bio from your colleague. Um,
Oh, she's an associate professor at University of Pennsylvania. I'll be doing most of the talking, but I'll introduce her if she
okay, so
also wants to speak.
oh yeah, perfect. So I'll introduce you and you introduce her. So
Yeah.
perfect. Okay. Hi, Dennis. How are you? Thank.
Good, how are you?
Hi, Katarina. Hi, Nari. Pleased to be with you
Hi.
all.
Yeah, we'll start in around 3 minutes. Let's give people time to arrive. I'll also have to ping people in. So yeah, 2 to 3 more minutes.
Okay.
Can I start with a prelim question?
hmm
How many different... So I'm aware of... My model for tonality of language is Chinese, and there's 5 tones in that. How many different languages are we going to cover today?
Today I'll be just talking about Mandarin. So it's just going to be 4 tones plus a neutral tone. But I didn't include the neutral tone. So since whether that's really contrastive is a different topic, I guess. So yeah, we'll be just covering Mandarin. I'll be just doing some intro to intro and covering some other languages and like how musicality affects them, but we won't be delving into other tonal languages other than Mandarin.
I'm sure it will make for a fascinating discussion.
I'll look forward to it.
I can ask another sort of background question. Is Mandarin a language that you're fluent in?
I'm not a speaker of Mandarin. My co-authors are, so they gave me more insight on this and the corpus. Um, yeah, I've been working with this corpus and other Mandarin corpora for quite a long time, so at least for tones, I'm pretty um, comfortable with working with.
Do you have a favorite word in Mandarin?
A favorite word in Mandarin. I've been working with like children data. I don't have a reason why, but I find, I mean, I guess just because always we get a lot of tones in them, like ma or mai, and not necessarily restricting myself to the actual meanings of the words, but like the sound, and because there are all types of tones that can align with it. I like those.
Ma as in ni hao ma?
Yeah, or ma as in like it can also be horse and mother, and so yeah,
All the meanings, yes, it should be fun.
all the different tones and meanings that can. Oh, let me invite my co-author and my if I click invite on stage, does that move her to um the list of people who can talk?
Just let us know who it is, and as soon as they enter, let us know, and I'll make sure to bring them up.
Oh, it's Jinjin Kwang.
It,
She's already
okay,
here.
is it the snowman? Okay,
Yes.
all right, here we go. Invited to speak. Perhaps she's away from keyboard. She has an
Okay.
invite. And then if anyone else in the room would like to invite others, you can hit the box with an up arrow on it, depending on which version of the software you're on. And you can invite people from there. You can share on Clubhouse or your other social media. You can copy a link and direct message it to people. Please go ahead if you want to do that right now. Thank you, Jonathan, for your share.
Yeah, thank you for coming. I think we can slowly start, and then we can always give very short summaries for people that came in late, maybe. So I'll just start introducing Nari, and then we go from there. So, welcome everyone to the Science Society. Thank you for coming. We really appreciate it. And yeah, we are very honored today to have our guest speaker, Dr. Nari Rhee. She is speech scientist and a computational linguist, and she's finishing up her PhD in linguistics at the University of Pennsylvania. Her PhD thesis investigates the many-to-many mapping between cues and categories in speech, with a particular focus on prosody. Nari did her bachelor's in computational linguistics at UCLA and will be starting to work at Apple in the Siri team in Seattle starting April 2022. That's very soon. So, yeah, thank you so much for taking the time in such an exciting time of your life. And we are very honored to have you, and the stage is yours.
Thank you for the introduction, and thank you so much again for having me here. I'm very excited to be able to talk to a completely new group in a completely new setting. I'm not too familiar with the this kind of setting and talk. So at any point, if you have any questions, just feel free to just speak up or raise your hand, and I'll um, let you ask the question, ask away. Katerina has already shared the paper, so if you want, you can have that up in front of you as I go on. So I'll delve right into the talk. It's musicality and age interaction in tone development. As humans, we all appreciate. Oops, sorry. We all appreciate some form of music, right? Music has always been part of our lives, dating back all the way to our early ancestors, like 40,000 years back, who made like rhythmic instruments using bone pipes. Today, we still enjoy music, whether or not you actively listen to music. From childhood, our mothers or fathers would have sung lullabies for us when we were babies. And there's always background music in the Netflix shows that you watch. So we all have music all around us, but our sensitivity to the musical components are different. Some individuals are more talented at music, while others can be tone deaf. And others can also take music lessons and become better at it. The term musicality that we'll be using throughout this talk refers to an individual's cognitive capability for music, shaped by both innate aptitude and musical training. At one end of the spectrum of musicality are the individuals with congenital amusia, a neurogenetic disorder that affects the processing of musical cues. These congenitally amusic population make up about 4% of the general population. At the other end are perhaps those with absolute pitch, the rare ability to label musical notes of a given sound without external reference. While most people fall in neither the most advantaged nor the disadvantaged portion of the musicality spectrum, individuals' musical processing abilities can also improve with musical training and exposure. Among various music-related cues associated with the term musicality, the pitch processing aspect of musicality has particularly received attention from language researchers such as myself and my colleagues, in how the advantages or deficiencies in pitch processing skills transfer to the linguistic perception and production of pitch cues. So the question that people have been asking is, what effect would musicality have on the perception and production of pitch cues used in languages? Many researchers studying both first and second language acquisition have shown that individuals with higher musicality have some advantage in language learning. Today, we'll focus on the effect of musicality on the development and use of people's native languages, so first language acquisition only. Previous literature have found a positive effect of musicality on various aspects of first language acquisition, including verbal memory, verbal intelligence, reading, vocabulary, syntactic processing, phonological awareness, and phonological processing. So a lot of things, many aspects of language show some positive correlation with musicality. But out of all, the effect was strongest and the most direct on the processing of prosody, because prosody is the suprasegmental element of speech, including tone, intonation, stress, accent, rhythm, emotion, that are communicated over different phonetic cues such as pitch, the length of sounds, and the loudness or the voice quality of the sounds. And such cues are exactly the cues that are that musicality is associated with, and the tests of musicality would assess. Okay, so being fluent in a language means two parts. You can listen and perceive and process all the cues of the language, and you can produce the utterances in the language. Let's start with production. Regarding the effect of musicality on speech production, scholars have found that regardless of their musicality, adult native speakers of a language can produce the prosodic phrasal F0 contours of global rises, like questions, and falls, like in statements. Furthermore, speakers of lexical tone languages, such as Mandarin or Cantonese, also have no problem in producing the lexical tones, which involve a very local and fast manipulation of vocal pitch. So in short, it seems that there is a positive effect of there is no positive effect of musicality in producing native prosodic cues in the adults. On the other hand, though, regarding the effect of musicality on prosodic perception, scholars have found that there is indeed some effect. In fact, adults with musical experience were better than non-musicians at detecting manipulations of the pitch of the final words in the sentences. A similar effect has been found for German, Canadian French, English, where listeners with amusia were worse than non-amusics, so typical population, at discriminating statements from questions on the basis of the sentence final intonation contours. Musicality also influences lexical tone perception. Native speakers of Mandarin and Cantonese with lower musicality are less accurate than the controls in their tonal discrimination, and they also show reduced categorical perception of tones. So the boundary of the tones perceived were less steep and less distinct for the non-musicians, or the lower musicality group. So since production has no association with musicality, but perception does, there seems to be an asymmetry in the effect of musicality. Now, but this was all for the adults. What about for children? Studies have shown that prosodic development starts very early, but recent work has also found that development of adult-like prosody is not complete even in early adolescence. Can musicality boost the development? While there are fewer studies on children, there were a few studies on French and Portuguese-speaking children on their ability to perceive pitch differences in prosody, or in the phrasal intonational contours. Just like the adults, the studies found that musician children were better at detecting the small differences in pitch in prosody. And to my knowledge, there are even fewer studies on the effect of musicality on the production side, so the production of prosody for children. But one study on Dutch learning 4 to 10-year-olds have found that higher musicality is indeed positively correlated with a more adult-like prosodic realization of focus marking, and this correlation became weaker at older ages. But for tonal languages, to my knowledge, there are no studies investigating how the native tone language development is affected by musicality. Hence, our study is to fill this gap, at least from the production side of things. So is there any musicality advantage on the production of tones for native tone language learning children? Jinjin, did you want to say something?
No, I just clicked.
Oh, okay.
You continue.
Okay.
Sorry to interrupt.
Oh, no. Let me quickly introduce my co-author and my advisor, my supervisor of my PhD program. So she is Jinjin Kwang. She's an associate professor at University of Pennsylvania in linguistics, and she can join and fill me in whenever you have any comments to add, or if you have any questions specifically for her, you can also ask her. Okay, so we've covered most of like musicality and the effect of musicality on what we know so far from the literature on what we on the effect of musicality on prosodic development and from both production and perception sides. But now, before we go on, I want to talk a little bit about what pitch is really. So pitch is a very important cue in languages, as we all know already. Because information about the tone, intonation, stress, emotion, all these things are all distinguished via pitch cues. The ability to process and produce pitch cues accurately is central to the accurate speech perception and production. So far, we've been referring to pitch as equivalent or a similar concept of as the fundamental frequency of the vocal sound. The term pitch is actually the perceived frequency defined as high versus low in perception. But the perceptually equidistant difference in pitch or in Mel scale does not linearly map to the actual frequency in hertz. And furthermore, this is affected also by other covariant cues in production of this vocal pitch. The F0 of voice is, of course, a very important acoustic cue for pitch, but there is also an important acoustic cue that is less discussed in the literature. That is voice quality. So listeners perceive higher pitch when tenser voice is used and lower pitch when breathier voice or other creakier voice is used. So let me try to demonstrate this since we don't have like slides for us to look at. I can quickly demonstrate what this really means. So when we reach high or low, like extreme F0 targets within our F0 range, the tension in the vocal folds also build up or loosen up. So when I produce the same F0 but with different voice quality, you will perceive different pitch. So let me try to demonstrate this. So when I say ah versus ah, you can hear the differences in voice quality, right? But studies have also found that the differences in voice quality also affect the perception of pitch in this. Yeah, so like the voice quality also affects the perception of pitch. And so let me try to give you some more examples. So when I'm gonna say 2 sentences, and you should try to see if the apple in the sentence is higher in pitch in the first sentence versus the second sentence. So give me the apple again versus give me the apple again. So because I am not very good at controlling the voice quality, I mistakenly also made give me the again part also breathier in the second sentence. So I'm not sure if that really had that was a good demonstration of the how voice quality affects your perception. But if this was done correctly, more people would respond to saying that respond by saying that the second apple in this sentence in the second sentence was actually lower in pitch, even though in F0 it was identical. So if I have successfully demonstrated that for you, there's more evidence showing that even for lexical tone language speakers or listeners, tones are also produced with reliable and co-varying voice quality or spectral cues. So I'll be referring to voice quality cues as also spectral cues because information about voice quality can also be measured in the spectrum through spectral tilt or spectral noise. And these cues have been shown in the literature to be correlated with the different voice quality, like the tenseness in the voice. Okay, and so spectral cues are useful enhancement cues to pitch in tone production, as I just mentioned. And so in investigating the musicality effect on Mandarin tones or Mandarin prosody, it is also essential to investigate what the effect is on each acoustic correlate of pitch cues, including not only F0, but also these spectral voice quality cues. So in this study, we test 2 things: whether Mandarin learning children with higher musicality have some advantage in the acquisition of the 4 lexical tones of Mandarin, and whether the musicality advantage holds for the production of all acoustic correlates of pitch. So if there's any question right now about the background and the motivation for this study, I'm happy to answer them now. Otherwise, we'll delve in right into the methods.
I do have a kind of a basic question, I guess. What is the difference between pitch and frequency? You also mentioned the fundamental frequency, and so if you can distinguish, yeah, great, thank you.
Sure. So the fundamental frequency, so frequency as in like the hertz, the number of cycles in the in a given period, like how many cycles of the same sorry, let me try to rephrase that. so the frequency of a sound is how many cycles of the same oscillation are, and the fundamental frequency is what is the lowest sorry. So there's going to be in vocal pitch, or in usually when we listen to sounds, it's actually going to be a complex sound. It has multiple components, and this is because it's a complex sound, it has multiple frequencies that are involved. But the fundamental frequency is the lowest frequency of the complex sound that we listen to. So when I say whether that if that's like, for example, 120 hertz, that is when that is the fundamental frequency that we're talking about. Yes.
I suppose it's probably you're talking about the vocal, maybe larynx, the organ larynx that can, the lowest frequency that the larynx can produce. Is that correct? The fundamental frequency.
Yes, the lowest frequency that the larynx that is producing is that can produce. Sorry. So the fundamental frequency is just by the definition. So in the waveform, in the periodic waveform, what is the lowest frequency? It's not necessarily the lowest sound that you can make with your larynx, but it's just the lowest frequency that is. So
If, for
because
example, the on a guitar 440 hertz is the note of A, what would be perhaps a reference frequency in this discussion?
I would think that on a guitar, you have a string, and then the lowest frequency would be the standing wave that when you have because the string is fixed on both ends, and then there's one basically half of the wavelength that forms the whole length of the string. That's the lowest frequency I can produce. So I think that probably the vocal that would be the lowest frequency that the larynx can produce. I would think so, right? And of
Maybe
course, I
we can
mean
help you. Yeah, so the fundamental frequency, so our vocal fold is not just a string, so it's actually like has a 3D structures, pretty complex. So the biggest mass, it's like vocal fold is also not just a thin string, it also have some mass and thickness. So the fundamental frequency physiologically actually corresponding to the rate of the vocal fold vibration, like the biggest mass vibration rate. So that's the fundamental frequency. So what Nari explained is in the acoustic domain, that's kind of when we talk about every sound can be decomposed into multiple frequency component, and the fundamental frequency is the lowest, like the longest repeating pattern in the waveform.
So is there a difference between pitch and frequency?
So pitch is in the auditory domain. It's what we interpret, what our ear and the brain interpret the frequency. Yeah, but that's different. Nari can talk more about this.
yeah, sure. So yeah, thank you for filling me in, and thanks again for the clarification question. So yeah, so in the physiological domain, that is, yes, indeed, the sound, the frequency of the vocal fold vibration would be something that's matching the fundamental frequency. But fundamental frequency is actually in the acoustic domain. So when we analyze or when we record the sound of the vocal fold vibrations, we get some waveform, right? And then the period that is the longest period that is repeating will be the frequency of the period that is repeating would be the fundamental frequency in terms of the acoustic sense. And then this also is correlated, not entirely linearly, but correlated with how we perceive the sound. So usually up to about like 1,000 hertz, it is said to be quite linear. So like when we listen to like we hear that it has an increasing pitch, right? And pitch, so what we mean by pitch is this perception of sound, perception of whether it's high versus low in sound. And it tends to be correlated with fundamental frequency and the vibration of the vocal folds. But as I was just kind of explaining earlier, the perception of the F0 or the fundamental frequency is not just, or the perception of the vocal fold vibration is not linearly mapping to the actual actual fundamental frequency in acoustics. And there are more factors that are playing into the perception of this pitch. And these other factors that are playing into the perception of the pitch includes cues in the spectrum, such as like, is the spectrum like more tilted versus whether it's more whether it's flatter, and whether there's more noise in the spectrum, like with more like breathiness, versus whether it's like just less noise in the spectrum, like like very tense. So yeah, more things are involved in the actual perception of pitch, but usually in the literature, people just discuss pitch as the perceptual correlate of fundamental frequency. And I was just saying that indeed that is not quite that is a good proxy of pitch, but it's not a complete like one-to-one mapping and a linear mapping. So it has to be taken with caution, and more studies should also investigate other cues that affect the perception of pitch, such as these spectral cues.
So would that be accurate? Say, let's say the pitch would be, let's say, something like if I do a spectral analysis, meaning that do a Fourier, the decomposition, and then if I plot the amplitude of sound.
Yeah.
If I plot the amplitude of sound against the frequency, would that be pitch? Would be, let's say, a Gaussian shaped curve centered around the one frequency, and then there's a kind of a envelope, a Gaussian shaped curve around it, and then depending on the width of the spread of the Gaussian curve, there's different perception of pitch. And so is there like a more kind of this kind of analysis and definition of pitch?
So I think I get what you mean, but just to clarify, so you're saying if we were to plot the amplitude against the frequency, but you mean frequency of the fundamental frequency or the different like spectral components?
Yeah, spectral components. So if I do a Fourier transform or Fourier
Yes.
analysis, and then I plot the the y-axis is the amplitude of each frequency, and then I have different frequencies. X-axis as the frequency, and then would I be close to describe a pitch? Let's say this envelope, this Gaussian curve, and then the center or the high peak is centered around one frequency, and then it spreads around, and then you have.
If you do like a spectral decomposition, if you plot the amplitude of the spectral components against the frequency against the amplitude, you'll get like not a Gaussian, but like a if because if that's like a vocal sound, vocal fold vibration, you'll get like a slightly falling slope. So the lowest component in that in the frequency versus amplitude domain. So if that's like, for example, 100 hertz, that's actually your fundamental frequency. And then at each harmonic, like the multiple of that fundamental frequency, you will get some amplitude, and that's going to be your harmonics, and you'll get some amplitude at those. But the fundamental frequency is usually also the loudest, so it'll be the highest, and then it'll like fall, and get closer to zero when it reaches like a very high frequency, like at, for example, like 10,000 hertz, there'll be very low amplitude.
I see. So would you say, let's say, with the same plot, would you basically you're saying it's like an exponential decay with the highest frequency at the lowest, I mean, highest amplitude at the lowest frequency, and then decay as the frequency increases as an integer multiple of the fundamental frequency, right?
Yeah, that's approximately right. So it's the first harmonic, the fundamental frequency isn't necessarily always the loudest, but it is usually around there. That has the loudest, the highest amplitude, and yeah, and then it just becomes like a decay, and the rate of decay is the spectral tilt that I've been talking about. And so a breathy sound like a ha sound will tend to have a faster decay, versus a ah, like a tense sound, would have a pretty flat slope, like or at least a not as steep spectral tilt. And so that's where you get the voice quality information from the spectrum.
So you're saying that basically, however you produce the sound, however it's high pitch or low pitch, the fundamental frequency always has the highest amplitude. It's only the house decay. If it decays faster, then you perceive the sound as lower pitched, and then if it decays slower, you perceive the sound as as of higher pitch. Is that correct?
So for the same fundamental frequency, if it's higher, if it has steeper spectral tilt, then it'll be perceived as usually lower in pitch than tenser sounds with a flat spectral tilt. But if the fundamental frequency changes, then of course the perception of pitch will be primarily be controlled by the fundamental frequency. So if that goes up, then the perception of pitch will also go up. But then for the same frequency, if it's breathier versus tenser, or has steeper spectral tilt versus not as steep, then you'll get a different perception of pitch, is what I was saying.
I see. So maybe the fundamental frequency you can change by, let's say, muscle controlling the
Yeah.
larynx. Okay.
Yes.
Yeah, and then the size of the vibrational area. Is that correct?
Yeah. And then by changing like the voice of the vocal tract, like other parts of your vocal tract, or by the how much air you're allowing through during your vocal fold vibration, you will get a different spectral information, and that's also very different voice quality.
Okay. Yeah. I guess also the mouth, the space, the volume of the mouth, and then the wall of the mouth.
Yeah.
How that vibrates as well, I guess, right?
Yeah. So like if we were to divide the source, like the vocal fold part, and then the filter, the vocal tract part, so like through the mouth, and the the vocal, like further down in your mouth, there's like a area where it can also resonate, right? So the filter part will also play into how the sound is perceived, and the vocal source part, just a vocal fold or a larynx vibration, will, of course, is the source, and so that's also going to affect the perception. But even if we weren't to look at the source part, depending on how much air you're allowing in the actual source, it'll already kind of change the spectral information. So there are multiple components to this, like the multiple factors that affect the spectral information and the fundamental frequency. But that's exactly, I guess, like what we were saying, is that we should pay attention to all these factors, or at least some of the factors that are known to affect the perception of pitch.
So if I scale up the magnitude just by a constant scale, and but the distribution is all have the similar shape, does that also affect the perception of pitch? What I mean is like the plot I mentioned before, the magnitude versus the frequency. If I just multiply the whole profile by a single constant, would that also you still have the similar kind of geometrically in the similar shape of the profile, but
But it would change
does
the
that
megahertz output.
megahertz? No, the frequency is the so basically the frequency profile is similar. What I do is just multiply the magnitude by a constant for the whole
Yeah.
frequency. Does that affect the perception of pitch?
I don't think it would, but it'll just sound louder, right?
Yes, and then
Yeah.
all the same distribution of the energy
Yes.
all over the frequency. So
Right. So
so
that
yeah.
wouldn't change the tilt information. That would also not add any noise, spectral noise. So that's not actually changing at least the two dimensions that we were talking about, spectral tilt and spectral noise. And also the fundamental frequency also wouldn't change. So that's just making the sound louder, not louder, not necessarily changing the pitch. So I don't think multiplying by a constant would change the
Cool.
perception
All
of
right.
pitch.
Thank you.
Any other questions about anything we've covered so far?
Hey, Nari.
Hi.
Hi, yeah, this is Rhee. Since, we probably don't have you for a lot of time, I thought it would just be nice if, you maybe just go through the rest of your work, and then if there's more time at the end, then we can ask more questions because we want to make sure that you get through everything.
Okay.
How does that sound?
Yeah, sure.
Okay, yeah, we don't
All
want to
right.
waste too much of your time if, it's nighttime, Yeah, yeah,
It's
please.
yeah. All right. I'll go right it. I'll go right into the how the experiments were done. So we had a total of 43 typically developing monolingual Mandarin-speaking children between the age of 4 to 6 years, and they were recruited from some kindergarten in Beijing. And so these children participated in a speaking and a listening session, and the sessions took place on different days. In the speaking session, children produced 80 to 160 subject, verb, object sentences in a semi-spontaneous game setting. And so there are 4 tones in Mandarin aligned at each syllable. So tone 1 is a high tone, and then tone 2 is a mid-rising tone, and tone 3 is a low dipping tone, and then tone 4 is a high falling tone. And so these subject, verb, object sentences that children were producing were all 3-word sentences of the type, the little rabbit throws the book. So it's like 小兔认识, and I'm not a native speaker or a speaker of Mandarin, so I'm not sure if that was done properly, but so what I mean is the subject is a single word, and then object or verb is also a single word, and then the object is also a single word. Acoustic cues were extracted just from the verb part, so that 1 syllable verb. And we extracted 9 time normalized subsegments from the verb syllable because we wanted to capture the various acoustic cue movements like pitch or F0 movements and the spectral movements as well. In addition to F0, again, so we extracted information about the voice quality through the spectral cues, and the cues specifically measured were capsular peak prominence for capturing the aperiodicity in the signal, and also various relative amplitude differences of the lower and higher harmonics. So we were just talking about the spectral tilt, right? So like higher harmonic minus the lower harmonic minus the higher harmonic will give us like the basic spectral tilt information. So those spectral cues are the ones that we measured. And all the acoustic cues were min-max normalized by speaker and recording session. And tokens with loud background noise or wrong target words or octave jumps in the F0 tracking were all systematically and manually removed. Okay, and additionally, to illustrate how these 4 to 6 year old children's production data are comparing to older children, we adopted the production data from 7 to 8 year olds from our previous work, and this was also collected under the same design but without the musicality testing part. So we don't have musicality information from the 7 to 8 year olds, but we have the production data. So we'll be able to see, at least in production, whether our high versus low musicality groups of the 4 to 6 year olds are comparing to the 7 to 8 year olds. All right. And then the musicality part, we were assessing the musicality of the children using the tonal subset of the primary measures of music audiation. And this is a test designed to measure the musical aptitude of children in primary grades, kindergarten to grade 3. And for each question, participants were instructed to listen to 2 short melodies and then indicate whether the melody was identical or not. Given the short attention spans of the younger children, 4-year-olds were given 20 questions, and older children were given 40 questions. And the musicality scores were evaluated by the percentage of correct responses, and also by doing a grade-based percentile norm ranking. So what that means, we can see from figure 1, if you want to pull that up from your from the link that Katerina has shared. We see the musicality differences among the 3 age groups in figure 1. So on the left, we have the raw score, so that's the percent correct, and the percentile rank on the right is the normalized scores. So yeah, and I must also kind of briefly mention that the normalization on the right were based on American children, so it was actually taken from the testing set. It already provides some normalization for us, so that was used. And so there is some caveat in doing this normalization, since these are Mandarin-speaking participants, and we're normalizing them by the musicality of American children. So there might be some like environmental different, their experience or language experience would have some difference effect on the musicality, maybe. And maybe that's also why we're getting a very high performance across all age groups. But regardless of what that tells us, the raw scores, when we look at them, we see that the musicality is increasing. And so the 4-year-olds are the worst in terms of their performance on the musicality test. The 6-year-olds are the best. But when we normalize them by their grade, it kind of removes the effect, and it's no longer a statistical significance difference. So what that means is, for their age, each recruited participant group in that age are basically typically developing. So the speed of development between 4 and 5-year-olds are not necessarily faster or slower than the development between 5 and 6-year-olds. So from this we learn that the musicality is indeed increasing, but the rate of the musicality development is pretty typical in our recruited participants. And so we decided to use the median of each age group to obtain the high versus low musicality groups for each age group. So we have the 4 low musicality group and then the high musicality group split at the median, same for 5-year-olds and then same for 6-year-olds. And this was done to employ automatic classification of tones on their production data to quantify the tonal contrastivity. So how contrastive are the tones in their production? So like how distinct is tone 1 from tone 4, tone 1 from tone 2 from tone 3, on and on. So this is a pretty I guess new methodology to use in at least this area, so like linguistics. So automatic classification was specifically chosen because it is very useful in assessing how well a given set of cues could be used to identify the class categories. Yeah, so by extracting the accuracy of the automatic classification, we can tell how informative the acoustic cues are. So for each age and musicality group, 3 sets of acoustic cues were used for tone classification. So we used the F0 cues and then the spectral cues that we were talking about. And then finally, both F0 and spectral cues, which is to investigate how the cues were integrated in manifesting the tonal contrast. We can go directly to figure 2. So we also wanted to verify the results across different assumptions about the linearity and the organization of the multidimensional acoustic space. So we tried 3 different classification algorithms as well. Linear discriminant analysis on the left, LDA, support vector machine on the right, SVM, and then random forest in the middle. And I must also tell you that we did classification with a 10-fold cross-validation split with 100 trials. What that means is we used 90% of the data for testing or training, and then 10% for testing. And the testing and training process was repeated 100 times with different splits or different samples from the data. And the accuracy score that we're reporting here is thus a pretty valid and generalizable accuracy, and because it has been cross-validated. Okay, so let's go to interpreting the results. So if you see figure 2, we'll see that in red solid lines, we see the accuracy from using F0 cues in LDA with using LDA random forest or a support vector machine. But let's not talk too much about how the algorithms were different, because if we just look at it, we see that the results are actually quite similar. It seems that the different classification algorithms did not necessarily give us different results. So let's just, because it has the highest accuracy, let's just look at the SVM results. So if we follow the red line in the SVM plot, we see that the 4 low musicality group and then the 4 high musicality group has a very steep difference, has a very big difference in accuracy when using F0 cues. And then between 5L, the 5 low musicality, and then 5 high musicality groups, the difference is a little bit smaller, but it's still, there is a big, at least some difference. And then between the 6 low musicality and then 6 high musicality group, it's pretty flat. There's only a very small difference. So what that tells us is, and all of this is still worse than the 7 to 8 year old accuracy using F0 cues. So what that tells us is that for F0 cues at least, the effect of musicality is stronger in the in the younger kids. So in the 4-year-olds, it's pretty big. 5-year-olds, it's maybe a little bit weaker, but it's still there. But the 6-year-olds, by the age of 6, it just kind of becomes much smaller. It just subsides. Okay, so that was for F0 cues. Now let's look at spectral cues. When we look at spectral cues, it seems that the accuracy is just generally very low. Spectral cues are not the primary cue of tones either, so it is not too surprising to see that the accuracy is lower. But we do see that the pattern is overall quite similar to the F0 cues. It seems that the musicality effect is there only in the younger kids. And then finally, at the age of 7 to 8, it just becomes much better. But now the actual interesting part comes when we look at F0 plus spectral cues. So what this is assessing is, on top of F0, which is the primary cue, when we add the spectral cues, how much additive information are we adding? And how much does it help in classifying or identifying the tones? And so that is the blue line, the blue dotted line. And when we look at the 4-year-olds, we see that it's actually quite parallel to the F Syracuse, and it's not necessarily even better than F Syracuse. But for the 5-year-olds, we see that it's actually it's pretty similar. It's also a little bit lower for the 5 low musicality group. But then for the 6-year-olds, we see that there is not much musicality effect, but it also goes well beyond the accuracy from just using F Syracuse, right? So that could kind of hint at us that, oh, now the spectral cues are becoming actually additive, and it's actually giving us more information about the tones. And that's regardless of musicality. So I went through this pretty quickly, but that's basically the results of our study. So for F Syracuse, we see that the effect of musicality is indeed there is an advantage with musicality for only the younger kids, so 4 and 5-year-olds. But for this, by the age of 6, it seems that the effect of musicality on the production of F Syracuse is pretty weak, or very minimal. It's almost like hardly there. For just spectral cues, it just seems like it's co-varying with, it's just parallel to F0. But when we look at the F0 plus spectral cues results, we can see that the in terms of musicality, there's not much difference, but the spectral information starts to become actually additive from the age of 6. So as a very short summary, for F0, there is an effect of musicality in the younger kids, and then for the integration of spectral cues in tones, it does not have any effect. Musicality has no effect, but it starts to become informative from the age of 6. So the lack of musicality advantage that we see in the 6-year-olds in our data kind of resonates with the findings of previous research that I mentioned on Dutch focus marking for Dutch children. So for in this study, the older kids also had a weaker association between prosodic realization of focus and musicality. So it seems that musicality seems to have some effect for the only the in the production, only in the younger groups, but it seems to disappear by some age, but it also depends by the prosodic structure, what we're assessing, and by the language. Regarding why there might be a musicality advantage in prosodic production only in the younger children group, we have hypothesized that maybe younger children who do not have a fully developed sensory motor mappings for precise vocal pitch control would maybe rely more on the auditory feedback from the perceived pitch during vocalization. So they pay more attention to what they're hearing as they make the sound in the younger children, maybe. But I'm open to discussion and comments regarding this hypothesis. That's almost everything I wanted to cover, so I'm now happy to answer more questions or hear more suggestions or comments from the audience.
Yeah, thank you so much for this great presentation. Yeah, please, everyone in the audience, please raise your hands if you have a question, or anyone here on the stage, please flash your mics if you have questions. And yeah, you're welcome to come up here and ask questions, discuss, comment. So yeah, please do. And in the meantime, I'll ask Nari a question. So, yeah, it's really interesting that in different languages you see similar results. I thought that was I don't know. I thought it was kind of surprising, but so I really like your hypothesis that you know your hypothesis that you stated. So, um, do you think that if you would test maybe like if you would do this study in children with different disabilities, or maybe autism and so on, would you hypothesize that there would be maybe a difference, or are you planning to maybe do so?
I would love to see more studies on this, but I don't have specific plans for testing children with some disabilities. But I would think that if the disability has something has an effect on the sensory motor mappings or the auditory feedback part, then it would probably have a different effect. So like musicality would have a different or like maybe enlarged effect, enlarged advantage on language development or prosodic development. But yeah, I would love to see more work on this.
Yeah, because I was thinking, because music therapy is I think there's such a big part in like autism and attention deficit disorder. I think that would be really interesting to study it the same way you did it. Yeah, I think that would be really great.
Right, yeah. Yeah, and
No, go ahead.
the methodology just makes it a little easier to test. Like you just need to get two groups producing different things, and then we'll just run automatic classification on the tones or some kind of prosodic structure. So yeah,
Yeah,
if
yeah, it would
anyone
be.
wants to do it.
Yeah, exactly. It's interesting. We had on Monday, so yesterday morning, we had the autism researcher here from Israel. She did like she's like the director of this institute, and she made basically this diagnosis framework that you can assess already under 1-year-old kids if they have high risk factor for autism.
Oh,
So I thought, yeah, maybe that would be interesting to bring you two together, or that she will read your paper and then maybe use that in her clinic. That would be interesting.
oh wow, 1-year-old. Yeah,
Not
for
1 year.
even younger.
Yeah, she continues treat, like they treat then, but they saw that the sooner you can basically see the risk factor, like the better it will be long term.
Right,
So.
right, yeah.
We're gonna have to open up a new class of participants for 1-year-olds.
Exactly.
No, that will be difficult, but very, very interesting.
All right, I had a quick question. So, if I heard you right, it seemed that the people in the 7 to 8-year-old category versus the 4 to 6-year-old category had a better performance. Is that right?
Yes.
And so, the first thing that comes to mind for me is that their brains are more developed. Is that, I know we're completely speculating here, but what do you think about that?
Right. Like we would also want to see if musicality has an effect in the 7 to 8-year-olds, but I would assume from the trend that we're seeing here, it'll probably have a very minimal or no effect, and that is probably because exactly what we were saying, brain development, language development. Most of the parts that we're testing here are probably nearly complete, and so we'll actually see something like a ceiling effect by the age of 7 to 8. And but there is something that I do want to say is that regarding the spectral cue development, we in a previous work we have found that the spectral cue development is actually not complete even at the age of 10 to 11. So yeah, so on top of 7 to 8, we had 10 to 11, and in that work we found that the spectral cues were actually not fully adult-like by then. So the development is not complete at this age, 7 to 8 or 10 to 11, but as you were saying, I think maybe because they have probably a more developed mapping between the sounds and the either in the language, so like actual production and language mapping, or in actually controlling the vocal folds independent of language. There will be multiple factors regarding like what part of brain development that is, but it seems that by the age of 7 to 8, they do have a pretty good near ceiling effect.
So the returns diminish basically as you get older. Is that what I'm hearing?
The return of musicality is they do diminish as they get older. Yes, but what we would really want to test is actually getting like so when we look at figure 1, we see that the performance on the musicality test, it just gets better and better, and it's already like beyond 90 at the point of age 6. And there will be more musicality tests available for older kids, but what we really want to test is if we get like A music children and A music children who are A music at the age of 4 and at the age of 10 to 11, whether musicality has any versus those who are not A music. If there's still no effect of musicality at the age of 7 to 8 or 10 to 11, we'll probably be able to say that, oh, musicality effect is diminishing by age. But what I'm saying is, as I mentioned in like the beginning of the talk, the A music population is quite small. It's like 4% of the general population, people say. So it's probably possible that we won't get, when we just recruit participants, they might not be all the way to all the way A music. So yeah, it'll be good to have like a broader spectrum of musicality every time we test this. But at least from the typically developing group that we got, it seems that the effect is diminishing.
Could we just define A music in case people were not aware of the definition?
Oh, A music meaning they are tone deaf and they are not able to perceive differences in pitch. And studies have found that amusia does affect the at least the perception of prosodic cues as well. And for the adults, though, it seems that the production part is pretty intact, regardless of whether they're amusic or not. But at what point the effect of amusia on prosodic production disappears is still remains to be studied.
It's just interesting that you mentioned that amusical participants were 4%, given that, you know, on a standard distribution, it'd be 1.5% on the edges.
I think it's just by the definition of like where the cutoff is, really.
Surely. CC, you had something? Oh, I think she's speaking.
I'm
We
sorry,
can't
I'm not
hear
a
you.
scientist.
Oh, I guess she dropped. Who else was that? Crystal?
Yeah, I'm sorry, I'm not a
Hello.
scientist. I just wanted to understand musicality. Like, what is musicality and what is. I'm sorry, I'm a bit clueless on the topic, so I just wanted to learn.
Oh,
Thank you.
sure.
I mean, I'm sorry, it's a very idiotic question.
Oh, no, no. Of course. So the term musicality I've been referring to is refers to the individual's cognitive capability for processing musical cues. And that's shaped by both like your innate ability to process musical cues and musical training. So basically, how good are you in in appreciating and processing the musical components, like such as pitch differences or temporal cues, is the part that the term musicality would assess, or the tests for
And
musicality.
does it extend to replication of the noises?
Um, I of noises. Can you explain
Well,
what you mean?
the ability to replicate the sound, whatever the sound may
Oh,
be.
I see. I think imitation is not part of the most musicality tests, so they don't necessarily test production when they do when they run musicality tests on such as these children or in other studies. There are multiple versions of musicality tests, so I think some of them actually do include like how well do you replicate or like imitate the sound that you heard. Um, but for the most part, people usually um, talk about musicality as how good are you in pitch processing and temporal processing of cues.
Does that answer the question, Crystal?
Yeah, well, there is a term, playing by the ear. It's not exactly. It's, I think, a few levels higher, a bit different from what you're discussing. Like, if you're a
Mm-hmm.
musician and you listen to a tune, you're able to play it by the ear.
Yeah.
Okay, and many of these people do not have any formal knowledge of chords and notes and all that, but they just intuitively, instinctively pick up the fretboard of the guitar or the piano keys. And I mean, it's a sort of a talent. It's sort of a more literal replication of what you heard, you
Mm-hmm.
know. But that's, yeah, that's just music. That's not audionics. That's not like vocals. Vocals is different.
Maybe that accounts for the differential between the normal curve of 1.5% and this finding of 4%.
Hmm. Yeah. Um, right. So like I mean there are people, so if we just focus on like pitch part, like the A music people would be like tone deaf. They wouldn't be able to tell whether two sounds were higher or different in pitch or not. But there's like the absolute pitch people who are able to even identify what frequency or like tune to that frequency without even like, or they're able to just pick up the guitar, tune it without a external reference, right? And that's like what people talk of,
Exactly.
yeah, say like
Exactly. Yeah.
absolute pitch. They already have, they don't need to compare. They just already know the frequency by heart.
You know why I asked this, why I said this, is that I would actually like to develop that ability. I've been trying to fucking learn how to play the guitar for 20 years, but I'm not a disciplined person, and I
You
have a
can.
spinal cord problem. Yeah, I have a spinal cord problem. So if anybody knows a spinal cord, like C3, C4, C4, C5, C5, C6, C6, C7, that's like pretty much my entire fucking neck. So if I hold the guitars right in front of me for more than 10 minutes, it's just, the pain becomes unbearable. So I, I've been trying to as quickly as possible, like in 10-minute spurts. You know what I'm saying? And you say this to a guitarist, they'll laugh at you. How can you play a tune in just 10 minutes? But here I am, I'm a problem solver. So this is what attracted me to you. I was like, okay, is maybe these guys could come up with a way that you could, in the shortest possible time, train your mind to understand a tune and with basic music knowledge replicate it. Well, that's my selfish interest.
Yeah,
I
if
know it's
there's
probably impossible.
You could start with the instrument you're born with, your voice, and learn to sing. And then it'll sound even better than your guitar, and you'll be able to sing longer, 20 minutes, 30 minutes.
And you don't have to carry, you can carry your voice with you everywhere you go. You don't need a case for it.
Yeah, and nowadays you have like your phone, so you can always just like have like a tuner on your phone, and then try to train yourself. Like, oh, I make like is that like a okay? I'm not an absolute pitch person, so I don't know what that note actually was, but you can like guess and then train yourself. Like, oh, that was actually an A, but I thought it was a C or something like that.
That's a good idea. Yeah, I can practice it, but I don't have a good voice. I can wake the dead up, or maybe kill those alive with my voice. But yeah, I
Oh,
love the sound of the guitar and the piano. So I mean, that sound in itself is like therapy. So when I hear the guitar or when I hear the piano, it's got a soothing and relaxing effect that my voice definitely doesn't have that effect on me when I hear myself speak or sing.
I'm sorry to go out of order. My name's Gary, and I play the trombone. And I'd like to say something that I think might be somewhat inspiring for Crystal Heart, if you don't mind.
Your volume is a little
So
low,
please,
Gary.
please, by all means.
Sorry, is that better?
Yeah, it's a little better.
Can you hear me now?
Perfect.
A little bit better?
Yes.
Okay. Because it's going to be maybe a little bit louder than this, but you can take some kind of guitar effects pedal and put your voice through it and do this. I'm going to press the button right now. And that was my voice. I was just talking. Ooh, that's all I did. And it sounded much better than my voice. In fact, that sounds like you're playing electric guitar. So if you want to sing and play electric guitar, you can actually have your voice sound like a guitar with a simple setup. Just ask your friend to get you a mic and a guitar effects pedal, and then you'll sound like that. You'll sound like that. It's possible, and it's fun.
You're right. You're right. I have guitar pedals. In fact, an even better idea that I've been exploring is like they have these light iPad or iPhone or whatever connected, basically the guitar necks. They're very, very light. And some of them, I had something called the iron guitar. It was like an old thing, and it sounded horrible. That was the only thing about it. And it didn't sound
I'm
that
sorry, we're
nice,
probably
But
getting way off topic. I really hate that I just burst in with that, but I thought that might inspire you to
yeah,
sing.
thank you very much.
It's cool that you already had that.
CC, you had a
Yeah,
question?
any other questions?
Well, we have Gary, the trumpet player. Is that you? Was that you, Gary?
Yeah, that was me. I'm the trombone player, and
I
I read an
remember. I've been in
article.
your rooms.
Oh,
I've
cool.
been
Yeah,
in
yeah,
your
I
rooms.
know, I
Your
know.
mother
Thank
was
you
there. Your
so much.
mother was there. I remember.
Exactly.
Yeah.
Hey,
Wow. Yeah. You're one of the
Nari
best.
and the experts, Katarina and Nari, I do have a question because I read an article many, many years ago and I was blown away by the article. I remember the feeling of eating breakfast at a hotel and picking up the newspaper. And there was an article about learning music improves your linguistic ability. And that if you're a student of music, piano, singing, whatever, you're listening to music, you're playing music, reproducing music, learning by ear, learning by reading the music, whatever you're doing, it improves your linguistic ability. I'm like, what? This doesn't make sense. And they said you can become bilingual easier, you can read between the lines and kind of catch what people are saying, and your listening ability to what people are saying becomes stronger. Your skill set in language is stronger through learning music. Does what you're studying and this studies that you're doing in tone reproduction and language, does that have something to do with that at all?
Certainly. So yeah, exactly what you mentioned. So there are people saying that like different aspects of language is learned much better when you have musical training, or like if you have higher musicality. So like it's not even limited to prosody. So prosody, as in like these super segmental elements with pitch and temporal cues, that's maybe a little bit more intuitive in imagining why musicality might actually have an effect. But like for syntactic processing, or reading, verbal, like memory, vocabulary, people have found that there is actually some positive effect, and second language learning as well. There's a lot of studies on this showing that musicality, for some reason, has a very positive effect on language learning. And so, yeah, it's related. And the reason why we focus particularly on like prosody is because it's more direct and it's more interpretable, and we can kind of imagine why that might be. And maybe from here we could expand on like explaining why there is an effect, a positive effect of musicality on other aspects of language acquisition, or second language or first language acquisition.
Yeah, you were when I came into the room, you were talking about Chinese students, Chinese kids, and I know that in Chinese people say there's musicality in the language, and the language itself has tones. The word for mother and the word for horse and other words sound the same to me, but they sound different for Chinese people. So ma 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 ma. So like people are singing. It sounds like they're singing when they're speaking, and I think that's really interesting. It's a close relationship between sort of musical, something musical and speech. But now the question then is, I guess the question for everyone is, why isn't everyone picking up an instrument and learning how to play? Like, is that a secret? Like, if I knew that that improved my language skills, I'd be going to learn the piano right this minute. So it just seems like,
Calluses on my fingers. I was trying to learn the guitar, but the calluses just, got worse and worse.
why
So
do
that's my
guitars
excuse.
stink? Come on, singing is bad. No, singing or piano or like something else, or you don't. I don't know. Like maybe but I don't know, it just seems natural that if you know that music has so many benefits, and it also soothes, and it's people use music for healing too, right? That you were talking a little bit about that earlier. It just makes sense that people should just bring music into their lives a little bit more. But yeah, I'm not going to tell anybody what to do. It just seems like it's a secret.
We're taking a turn into the realm of the vagus nerve.
I don't.
Right.
What is the
Yeah,
vagus
we
nerve? I'm
totally
sorry.
are. Denise, you want to explain that a little bit more?
Sure. So the vagus nerve is a nerve that runs from your brain down through at least your stomach, and there are internal and external vagus nerve stimulators, which are um, lawful to sell per the FDA in the United States. And what they do is they generate a megahertz tone. I don't know what they are, what those tones are, but via that mechanism, internal or external stimulation, you can increase what is called vagal tone. And people who have a better vagal tone, tend to have better health, as far as I understand. That's kind of a loose correlation. I'm not going to really qualify that. But the point is that if you are a singer, or you play an instrument, the drums, a sitting drum, whether you're sitting at the drum set like a hairband or something, or a guitar, singing, anything, that is an internal and external vagus stimulation. So that could, yeah, that's interesting interplay between biology and external forces.
That is interesting.
I dig it.
Yeah, that is definitely quite interesting. Nari, I wanted to check in with you on time because it's, coming to half past the hour, just to see how much more time you have with us, or, just let us know.
If there are any other burning questions, I'm happy to, or any suggestions or comments. I'm not running short on anything, so
Okay, all right. Just wanted to make sure.
yeah, thanks though.
Uh, does your study, do you think that this study helps support musical intervention in like pre-K or kindergarten before they turn 6 years old?
Sorry, can you repeat the question again?
So if someone hypothetically wanted to put funding in for music development and they just wanted to target it to the best ages, does this study kind of suggest that it should be before the age of 6 that they should to gain some kind of benefit, or am I misunderstanding?
Yeah. Yes, targeted to the younger children who are able to actually gain some like actually have some benefit from the musical training. But yeah, there is some caveat though. Like so in the Dutch study that I was citing, they found that the effect goes up all the way to like around 10 to 11, I think, or 10, I think. But for our study, it seems that it's for at least for tone learning, it's before 6 that has some musicality advantage. So for different aspects of language learning, it might actually differ. Like when is the time where you could actually still have some musicality benefit. But in general, I think younger the better.
Cool. Thank you very much.
Thanks for the suggestion.
Hey Frank, how are you? Do you have a question?
Hi, Katerina. Thanks, and Dennis for inviting me up. Sorry, I'm late to the excellent presentation discussion here today. Just quickly from the probably not educated from the previous discussion might have been asked. So this study has been focusing on one language. How about other cross like cultural, like English and other? Some languages probably have different pitches or tonality. I mean, probably this has been discussed. Sorry for repeating it.
No problem. Yeah, so for Mandarin, which is a tonal language, there is some musicality advantage at the before the age of 6. For the Dutch study that I was citing, it seems that before the age of 10, there seems to be some positive correlation between like focus marking through prosodic cues and musicality. There are some studies in perception in the speech perception side showing that at the age of 8, for example, in French or Portuguese speaking children, there is a positive correlation between their musical training and their ability to detect pitch differences in sentences. So I think it'll probably be quite cross-linguistic, that there will be some musicality effect, but as we were just discussing, it might at what age and the effect is stronger is probably varying by the prosodic structure that we're looking at, or by the structure of the language. Yeah. So yeah, that's, I think. Did I answer
Thank
the
you
question?
for the
Okay.
yes, thank you. So just curious, is the age 4 or 5 somehow related to the proning process in the brain in the neurons?
I'm not so familiar with this process.
The
Anyone?
I think Katerina will be an expert on that. I think we had this earlier discussion with Paul King on the newborn, the brain of newborn has the most redundancy in their neuron capability, and then to the age 4, I believe, is the hit the 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 high point of the the pruning starts to take place until some age of 18 or 20. I don't remember the exact, but you can look it up, I think.
Um, can you repeat the paper that you were mentioning, or the talk that you were mentioning? That was
Oh, sure. I'll look. I'll back channel you.
Oh, thank you.
Sure. Yeah.
And then, is there any reference point for English, given that it does not rely so heavily on tonality?
For English, in the speech perception, there was a study on British English for the adults, showing that for that musicality or a music population were almost almost as good as the non-A music population in their imitation of sentence prosody, sentence intonation. I don't think there were any on children, but I might be wrong. But I think in terms of like their reliance on tonality or like or pitch is used in all languages, but at different levels of the prosodic structure. So it could be at sentence phrasal level, or it could be at like the lexical tone level, like Mandarin. It does seem like the lexical tone, because it's at the lower level, it's probably um, it requires more faster pitch processing, but it probably extends to other levels as well. So that's why we're hypothesizing that it'll be for most, it'll be the same. The musicality effect will be the same for like different languages. Oh, and for that Dutch is quite similar in terms of their prosodic structure as English, and there we saw some effect. So, any other questions?
Yeah. If you have any other questions in the audience, please let us know. Or if not, also Nari is already speaking for 1 hour and a half, a little bit longer. So I also don't want to take too much of your time. But yeah, I think, you know, your work is so interesting, and you're starting your new job in April, so that's also exciting. So, so yeah, maybe I don't know if you will be allowed to share any updates on, you know, your research, but you're always welcome back to come here to Science Society. And also thank you, Jian Jing. I hope I said your name right, Professor. Thank you for coming and supporting. Maybe you, yeah, we can arrange another date again if you would like, with some research updates or future research.
Yeah, I'm glad to be here. It's very interesting society, very stimulating discussion. Thank you.
Yeah, yeah, thank you. Yeah, we have, you know, almost every day a guest speaker during the week. So yeah, if you're interested to hear about all kinds of different science current research updates, yeah, please come back and follow the club. We have tomorrow Dr. Kukuchi, who will talk about the experiments they did in the lab, and to show how cells eat. And then Dr. Cunningham from Oxford, he will come to talk about a white dwarf accreting planetary material. So he's a physicist. And then we'll have Dr. Priyadarshini about suppressing genes across generations. And on Saturday, how mitochondria act as lenses in cone cells. So yeah, we cover all kinds of topics, and the discussions are pretty interesting because people are from very different backgrounds. Yeah, the questions reflect that in the discussion. So I think it's a very unique setting here on Clubhouse to have these scientific discussions. So yeah, we really appreciate you coming here and joining us. So yeah, thank you so much.
Thank you. It was
Yeah.
great to be able to talk to a new audience, and I see like alerts about your society. I'm already following, and there seems to be very exciting talks. So join in whenever I have time.
Oh, thank you. I think I saw you the other day, but I think it was
Yeah,
kind
I
of
was there.
it was more spontaneous topic. We try to make like some days that we just have like roundtable discussion about a topic or a paper that we read.
I see.
Yeah, I think when you were there, that was kind of a room like that. So yeah. Great. So yeah, thank you everyone for coming, and yeah,
Katerina, just
please.
quickly,
Yeah,
I'll just
go ahead.
mention the reference. Neri, I see you have a party hat, so that means you're new. So if you can, follow me so that I can back channel the links. So far for the pruning, one direct link is Wikipedia. It's actually synaptic pruning. That's the keyword. And there are actually Google turns out there's, the answer probably is positive, affirmative. The pruning is definitely important in the process of early learning of language and music. So there are two links. If you're interested, I can also share with you. Yeah. Thank you. Thank you for your, yeah.
Great,
Yeah,
thanks.
thank you, Frank. So Gary said he was so kind to offer to close the room with some music since it was research about musicality. So I hope.
How could I not offer a little musicality for a research dissertation here from soon-to-be Professor Dr. Nori on music? So just 10 or 15 seconds before you close the room, just give me the cue when you're ready to close the room, and I'll play a little bit.
That's so perfect. Thank you so much. Yeah, that's the beauty of Clubhouse. We get like all kinds of people that are kind and nice. And yeah, and congratulations to, soon to be finished your dissertation. I know it's a stressful time. So congratulations.
Thank you.
Yeah, definitely. Congratulations on that.
So
Thanks,
Syria, she's also finishing soon her thesis. So, you both are having an exciting time in your life.
Saturday is my day.
Okay,
That's a
so
lot of
yeah,
work.
what a wonderful closing of the room. So Gary, go ahead, and we'll close the room in a little bit, but we'll listen to Gary. So
I'm
thank
just going
you.
to make this up. I'm going to make up 10 or 20 seconds of music, and then you just close the room when you want.
Okay, perfect. Thank you. Bye, everyone.
Thanks. Bye.
Thank you.